Okay, so you decide to jump in the shallow end. That's totally respectable. You know your limits. And let's start here. So solving for x, you might think, okay, well, 33 plus what equals 90? But I would caution you, we are not told that the larger angle is 90 degrees. As a matter of fact, it's not 90 degrees. Whoa. Sorry, I don't know what I did there. Okay, so if you see the right angle square, then you know you're dealing with 90 degrees. But because it's not there, I mean, yeah, I know I drew it, but we don't know that that's 90 degrees. So how on earth am I supposed to know the size of that second angle? Well, they're adjacent to each other, and because they both have one arc, this little single arc here, and this has a single arc, what they're really saying is that they're congruent. So that x is equal to 33. If they were two different angle degrees, different, I don't want to say lengths because it's not a length, but they would have, let me get the black one out here. They would have something like this. And so one would be a different size than the other. But because they're stating that they're both the same measure, x is 33. It's that simple on this one. Okay? All right, what about this one? Besides the fact that it's a little crooked. How are we going to figure this out? Well, I would hope that you would say, ooh, vertical angles. X is 62 because they're across from each other. But you might not be that confident. You'd be right, but you might not be that confident. What we can know for sure is that this 62 plus whatever this angle is, I'll call it y, is equal to 180. Right? Because this is a straight line. And so 62 plus, had to stop the video and figure it out, 118 is equal to 180. So this y would be 118. This angle here is 118 degrees. And that makes sense. It's obtuse. It's obviously greater than 90 degrees. So that's going to make sense to us. And the other one's acute, and it's going to be 62. So if we know that 62 plus 118 is 180, then let's look at my yellow one. Oops. Having all kinds of technical difficulties here. So we were looking at this angle here, and we said that's 180, and so 62 plus 118 is 180, but we can also look at it from this perspective here. And we know that 118 plus what equals 180? Well, it's still 62, right? So here, 62 plus 118 equals 180, and 62 plus 118 is also 180. And so that's why we know that when you have vertical angles made by two straight lines across from each other, they're going to be the same measure. So when you see a problem like this pop up, you can simply look at this and go, ooh, x is 62. And you'll put 62 in the box and be done without a lot of math. Why? Because you know your geometry. All right, Mrs. Evans, I thought you said this was the shallow end. Yes, this is not so bad. Excuse me, too much coffee. So here again, we have vertical angles. We have two straight lines that are running perpendicular into each other, and the angles across from each other are vertical angles. That means they're equal, they're the same. And so even though I don't have a solid measure for either side, I do know that I can set them equal to each other and solve them. So I can say 4x plus 2 is also equal to 5x minus 31. And now we pull out our algebra. Now we pull out those rules we learned back in January. We want to isolate the variable. Get all the x tiles to one side. So now I have 2 equals 1x minus 31. Now I need to get all my unit tiles to the other side. And I find that one value of x is worth 33. Now, that doesn't mean this is 33 degrees, right? Because that wouldn't make sense. 33 degrees is acute, but this is an obvious obtuse angle. Well, we know that x is 33, not the angle. X is 33. So if I did 33 times 5 and then subtracted 31, that would be the measure of my angle. What's 33 times 4 plus 2? Same as 33 times 5 minus 31. But they didn't ask us for the measure of the angle. They just asked us to solve for x. So the answer is x is equal to 33. Or you would just type in 33 and be done. All right, I think that's enough to give you guys some chances to practice. Good luck in the shallow end.